Okay, so we're going to continue today talking about the fundamental counting principle. And just a reminder, we were talking last class about counting methods and how many different ways can we arrange objects, or how many different arrangements do we have if, for example, we have this many options for choice 1 and this many options for choice 2 and this many options for choice 3 and so on and so forth. Okay, so that's kind of where we came from. We're going to pick up where we left off today, and we're going to talk about cases. Okay, so an example of cases would be something like, if I said something like this. Whoops. I need to get to my pen. Okay. An example of cases would be if I asked, for example, how many 2-digit even or 3-digit odd numbers can you make? Okay, that would be an example of a case problem. Okay, so for example, how many 2-digit even or 3-digit odd numbers can you make? Okay, now there's one word that sort of gives it away, that this is a scenario where we have cases. Can anyone see what that word is? Yeah. It's not digit. Yeah. It's or. Yeah. This or this. Case 1 or case 2. Yeah. Okay. So one thing that you really want to look out for cases is the word or. Okay. So I'm going to write it out here. Or. Either this or that. That's one thing. But then there are two other phrases that come up a lot that are almost subtle, that also indicate cases that you need to be aware of. And those two other phrases, the first one is at least, and the second one is at most. Okay? So for example, if I said to you, I'm giving you 5 questions to do. You need to do at least 3. What would be acceptable there? Here are 5 questions. You must do at least 3. What's acceptable? Yeah. 3 questions is acceptable? Sure. What else is acceptable? Yep. 5 questions is acceptable. What else is acceptable? Yep. 4 questions is acceptable. Exactly. So if there are 5 questions in total and you must do at least 3, the cases are 3 questions or 4 questions or 5 questions. Okay? So the other ones are at least. Okay? And then the third one is at most. Okay, so for example, I went to Good Earth the other day and I got oatmeal, and they said you can have at most 2 toppings on your oatmeal. Okay, so what are the possibilities there? What would the cases be? What could I have? Yeah. 0, yeah, sure, I could have it plain. I could have 0 or 1 or 2. Exactly. Okay, so these are the 3 things that you want to look out for that tell you that that this is a case scenario. Okay, or is usually the one that's the most obvious. But if you see these, you need to highlight them because these are the ones that usually get missed. Okay? All right, so how many 2-digit even or 3-digit odd numbers can you make? Well, we've got case 1, which is the 2-digit even. Okay? Or case 2, which is the 3-digit odd. Okay? Well, if we're building a 2-digit even number, where would we start? How would you start to figure out how many 2-digit even numbers there are? It's the first thing that you would put down on your page. Yeah, 2 spaces, because it's a 2-digit even number. So we've got to make sort of 2 decisions. Or there's 2 places where choices could go. That's a better way of putting it. Okay, there's 2 places where choices could go. One for the first digit and one for the second digit. Okay, so are there any restrictions here? Yeah.
Well, it can't be 0 because it has to be 2 digits.
Good. The first digit can't be 0 because if the first digit's 0, then it's not a 2-digit number. It's just a 1 digit. So here, this has to be 1 to 9. Okay, so how many options are there for the first digit? 9. And then what about the second digit? Yep. Has to be even. Okay, so what does it have to end in? 2, 4, 6, 8, or 0, yes. So this has to be 0, 2, 4, 6, or 8. Right, so there's 5 here. And we multiply those together. Okay, or case 2, this is 3 digits. How many spaces? 3, 1, 2, 3. Okay, any restrictions? Any restrictions? Yep. Yep, this has to be odd, right? So this is going to be 1, 3, 5, 7, or 9. So that also has only 5 digits that could go there. Okay, good. Any other restrictions? Correct. Again, it can't start with 0. So this has to be 1 through 9. So again, that's 9. What about the middle digit? Any restrictions there? No, that could be anything. So this is 10, right? This is basically 0 through 9. That could be anything. We're going to multiply these together. Okay. What do you think to get the total we should do with case 1 and case 2? Add them. Correct. Exactly. So when you have a case scenario, you want to separate the cases out. You want to figure out how many different arrangements there are for each case, and then add them together. Okay, so this works out to be 45 plus, this is going to be 5 times 9 is 45 times 10 is 450. Okay, whatever that is. I don't even care what the total is. I just want to see this work. Okay? All right. Okay, so now let's try another one. How many 5-digit multiples of 5 or 5-digit multiples of 2 can be made using the digits 2, 3, 4, 5, or 6 if the digits may be repeated? Okay. How many 5-digit multiples of 5 or 5-digit multiples of 2 can be made if the digits from using the digits 2, 3, 4, 5, or 6 if the digits may be repeated? Okay, well, what are the 2 cases? Are there 2 cases here? Yeah, okay, what are the 2 cases? Yep.
The 5-digit multiple of 5 and the 5-digit multiple of 2.
Correct. Multiple of 5, multiple of 2, and they're both 5 digits. Okay, so I'm going to kind of ignore that piece for now. So case 1, multiple of 5, case 2, multiple of, what is it? 2. Okay, and then they're 5 digits, so how many spaces do I need? 5. 1, 2, 3, 4, 5. And then for case 2, also 1, 2, 3, 4, 5. Okay. All right, so are there any restrictions for case 1? It's got to be a multiple of 5. How do you tell if something's a multiple of 5? Ends in 5 or 0. Okay, so restriction is going to be on the ending. What could go in the last digit? 5 or 0. But how many digits do we have to play with here? We only have 2 through 6. So of the ones that we can use, what's acceptable? Just the 5, yeah. So there's actually only one option there. Okay, what about the rest of them? What could go here? In this first digit? Okay, 0 can't, but is 0 one of the numbers that we're allowed to use? No, so we actually don't need to worry about it in here. Can we repeat these? Yeah, so this could be anything. 5 times 5 times 5 times 5. Okay, times 1. Multiple of 2? Okay, what could go in the last digit if it's a multiple of 2? 2, 4, or 6. So this is 1, 2, 3. 3 of them are possible there. And then what could go in the rest of them? What can go in the rest of them? Anything, yeah. Right, multiply them together. Add them. Okay. Question. Could you do this in one step? Could you? Do you need it to be a multiple of 2 or a multiple of 5? What really does it need to end with? Well, no, it can be either or. Either or. So what does it have to end with? If it's a multiple of 2, what does it have to end with in this scenario? 2, 4, or 6, or a 5. Could we just put those together? Could we just go like, there's 4 options here. It could end in 2, 4, 6, or 5. Would that work? Yeah. Well, so sometimes you can do questions in one step. Okay? Now, here's when you can do them in one step. Number 1, you have to have the same number of spaces for both cases, right? If I had tried to do that with the example that I did up here, where one of them is a 2-digit number and the other one is a 3-digit number, that's not going to work. Okay? So case 1 and case 2 must have the same number of spaces. Okay? The second thing that must happen is that these endings, where the restrictions are, can't have any overlap. So if I had thrown a 0 into the mix as well, then I'm going to have a problem, because then I'm double counting. If I had had a 0 in here and a 0 in here, then there's problems. Okay? But, and also if there were no repetition, if there was no repetitions allowed and there was a 0 in a mix as well, that would also create problems, because then I could have a 0 ending here and a 0 ending here, but then it can't start with a 0. Okay? But when it's a clear-cut case like this, where there's no overlap between these endings and the spaces are the same, yes, you can do it in one step. Okay. All right, questions with that? And again, like I trust, hopefully I'm crossing my fingers here, but I trust that you guys can plug in 5 times 5 times 5 times 5 times 1 plus 5 times 5 times 5 times 5 times 3 equals into your calculators. Yes, we're good with that? Cool. Okay, next. Julian is planning a trip from Calgary, oh, I can't talk today, to Denver, and the map shows the different flight options for a particular airline. Okay, so here are the flight options. So he starts in Calgary. There's Calgary. And he wants to go to Denver. Okay, so what are the options here? What could he do? He could fly straight to Denver, or, yep, layover in Seattle. Exactly. Those are our two cases. Yep. Why would anyone want to lay over in Seattle? Cheaper, yeah. Maybe better times, right? Maybe you want to fly on a Saturday, but the direct flights only go on a Tuesday or something, right? There's situations where you might want to do a layover. Okay, so cases. Case 1, direct. Case 2, layover. Okay, well, if he's going direct, how many spaces do I need for a direct flight? Just one, yeah. Okay, how many options are there for him to go direct? There's 2 options, yeah. Okay, for a layover, how many spaces do I need? I need 2, yes, because he has to go Calgary to Seattle, and then Seattle to Denver. Seattle's a pretty cool place, actually. I would stay over there if I could for a couple days. Okay, so from Calgary to Seattle, how many options are there? 2. And then Seattle to Denver? 3 times 3. Okay, and then we just add these together. So this one's pretty easy. We got 2 plus 2 times 3 is 6. So the total is 8. Yeah, good? Okay. All right. You guys try these 2. Questions 1 and 2 on page 10. Okay, let's talk pizza. Now, I have to say, anyone who's a vegetarian is at a serious disadvantage to do this question. And I know this because I'm not a vegetarian, but it's a bit complicated. I've never in my life ordered a pizza with meat on it. It's complicated. I'm Jewish. It's complicated. I'm not going to get into it. But I haven't ever ordered a meat pizza. And I was totally confused by this question. I got it in the end. I'll show you why I was confused once we go through it. But we'll talk about it. Some of you guys got it. I'm like, well done. You must have a lot of experience ordering pizza. My husband did really well with this question. He's got a lot of experience ordering pizza with meat on it. Okay. Kevin's going to make a pizza that must have sauce, cheese, and meat. Got to have those 3 things. He has a choice of 3 types of sauce, 6 different types of meat, 2 different cheeses. How many different pizzas can Kevin make if his pizza can have at most 2 meats? Okay, so what could Kevin have on his pizza? He's got to have sauce, cheese, and meat. So let's talk about this piece. At most 2 meats. Well, if it's at most 2 meats, how many meats could he have? Yeah. 1 to 2, because it says at the beginning that it's got to have sauce, cheese, and meat. Okay? If we were told that it didn't have to have a meat, then it would be 0 to 2. You'd be correct. But we're told that he's got to have sauce, cheese, and meat. So he can have 1 meat or 2 meats. Okay? Those are the 2 cases. Does that piece make sense? Yes. Okay. So case 1, 1 meat. Case 2, 2 meats. Okay. So if we're looking at case 1, how many spaces should we have? 3, because we've still got to choose 3 things. We've still got to pick 3 things. We've got to pick a sauce, a cheese, and a meat. Okay, for case 2, we've still got to pick a sauce, and we've got to pick cheese, but now we've got to pick 2 meats, meat and meat. Okay, how many options for sauce? 3. How many options for cheese? 2. How many options for meat? 6. So this one is 3 times 2 times 6. Okay, let's move on to case 2. How many options for sauce? 3. Options for cheese? 2. Options for the first meat? Options for the second meat? Okay, so this is the part where my mind was blown. You can get the same meat twice. It's true. Like you're ordering a pizza. Have you guys done this? You order a pizza from Domino's and you're choosing your toppings and you could just choose the same meat twice? It's true. And actually, I know. See, there's like a fight going on now. But you guys, I've done this. I haven't done it with meat, but my kids really like olives, and I've done it with olives. And they do charge me for 2 toppings. I've ordered 2 toppings worth of olives. The same olives twice.
That is absolutely horrific, and I hate that this is the world we live in.
Yeah. There you go. Now, let's be clear. If this question was out of 3 marks and your only mistake was that you put a 5 there, I don't even know if I deduct a mark. I might deduct half. I don't know. I can see where there'd be some confusion, some ambiguity there. I can see how some people in the class are already arguing. I can see how pizza aficionados would think that this is not cool at all. So depending on how much of a pizza snob you are, you might interpret this question differently. If your usual place that you order pizza from is Domino's, then you might understand this question differently. Are we all good? Okay. All right. Okay. So, we're going to move on. Now, sometimes we have a bunch of objects, but we're actually only going to arrange some of them. This comes up all the time, right? Let's say we're working with a license plate, right? Well, license plates in Calgary go letter, 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 number, 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 or letter, 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 number, 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 right? So we've got 26 letters and 10 digits. We're not using all 26 letters and all 10 digits in that license plate. We're only arranging some of them, okay? So sometimes we're given a group of items, but we only want to arrange some of them. So for example, combination lock opens with the correct 3-digit code. Each wheel rotates through the digits 1 to 8. Each digit can only be used in a code once. How many different codes are possible? Okay, well, how many spaces do we need? 3 for the 3 different numbers in the code. How many options do we have for the first number in the code? 8. And then for the second, 7, and then the 6. Okay, so this is an example where, yes, we have 8 objects, but some of them are going to be left behind at the end of the day. Okay, how many 3-letter arrangements can be made from the letters in the word trouble? Same sort of idea. How many letters? 1, 2, 3, 4, 5, 6, 7. We've got 7 letters, so this is going to be 7 times 6 times 5. Okay? All right, we're good with that? Okay. All right, so you guys spend like 5 minutes trying these ones. And then we're going to add an extra layer in here, as per usual.